Okay, here's your Unit 5 review video. So I'm going to do 2 of each type of problem. My recommendation is once the problem's up, pause the video, give it a shot on your own, see how far you get, restart the video when you're ready. That way you can get a gauge of how much you were able to do successfully, where you got stuck, where you got off. And then you can figure out whether or not you want to do the second problem as well. Again, there will be 2 of each type. So if you felt really good about the first one, then maybe you skip the second one. And you find the topics that you do need to practice a couple of. Okay, so here we go. First set comes with reducing your radicals here, or simplifying, I should say. So we have the square root of 36x to the 4th, y to the 6th. Okay, so go ahead and give this one a shot. Okay, and then you're going to want to pause the video pretty quick because I am going to immediately start walking through it and giving the work and answer. So here we go. The square root of 36, x to the 4th, y to the 6th. The square root of 36 is 6. The square root of x to the 4th, there are two pairs of x's inside of there. So we're pulling out an x squared in this case, or you can think of it as dividing this 4 by 2 because it's a square root, so 1/2. So dividing by the 4 by 2 would be 2. And then back here we would have y cubed. Now with this y cubed we do have an even becoming an odd, and so that one does need absolute value, guys. Okay, one more in this vein. We have the square root of 192, x to the 10th, y to the 7th. Okay, and so for this one we are looking at simplifying the square root of 192. Now the square root of 192 is not a perfect square, so we are going to need to break that down into its forms. And so in this particular case, if I were to divide out of 3, we would have left over 64. Now 64 is a perfect square, so I'm going to pull out the 8, which is the square root of 64, and I'm going to leave that 3 under the square root. Okay, x to the 10th reduces to x to the 5th. Now careful, we have even becoming odd, so that's going to be absolute values. And the y to the 7th, we have y cubed coming out, but there's still one y left over inside. In this particular case, we would not have absolute values around this y cubed because while we became odd, we were not even. We have an odd here, and so there would be no absolute values. Okay. Next up, we have the cubed root of 27, x to the 9th, y to the 12th. Okay. Now, cube roots will never have absolute values because, again, we need to be even becoming odd, and in this case, this is odd. And so cube root of 27, what times itself 3 times gives me 27? That would be 3. X to the 9th, if I were to divide that into 3's, we would have x cubed left over. And y to the 12th would be y to the 4th, if we were to do the cube root of that. Okay, and one more in this vein. Let's do the cubed root of negative 32, x to the 7th, y to the 11th. Okay, and so this one, we have our cube root of negative 32, breaking this down because that is not a perfect cube. This would break down to 4 and negative 8. Negative 8 is a perfect cube. And so I'm going to go ahead and pull out negative 2, but I'm going to leave that cube root of 4 inside. X to the 7th, we would have x squared coming out with an x left over inside. And y to the 11th, we'd have y cubed coming out with a y squared left over inside. Okay, and so that is simplifying radicals. Okay, next up we've got our rationalizing the denominator here. So this, we have 7 over root 3 plus 1. Rationalize the denominator. Okay, so here we go. For this one, we are looking at rationalizing the denominator, which means multiplying top and bottom by root 3 minus 1, because that would be the conjugate of this, root 3 minus 1. You also could multiply by negative root 3 plus 1 if you wanted to. That would be fine. Would make your work look a little different, but it should generate the same answer. So if you multiplied by negative root 3 plus 1 and you don't get the same answer as me, take a picture of it, send it to me via email. I'm more than happy to check your work and to help you figure out kind of where you got off there. But either way should generate the same answer. Okay, and so for this one, simplifying this, distributing that 7, we would have 7 root 3 minus 7. All over root 3 times root 3 is 3. Outside and inside we cancel. 1 times negative 1 is negative 1, which gives me 7 root 3 minus 7 over 2. Okay. And then one more in this vein, we have a root 2 plus 7 all over 3 minus root 5. Rationalize the denominator again. Okay, so here we go. We have multiplying top and bottom by 3 plus root 5. You also could multiply, if you didn't want to do 3 plus root 5, you could do negative 3 minus root 5. Again, same thing, should generate the same answer if done correctly. Okay, and so then foiling out our numerator here, root 2 times 3 is 3 root 2. Root 2 times root 5 is root 10. 7 times 3 is 21, and 7 times root 5 is 7 root 5. All over, we have 3 times 3, which is 9. 3 times root 5, and negative root 5 times 3 will cancel. Negative root 5 times positive root 5 is, oops, sorry about that, negative, and root 5 times root 5 is 5, which gives me a final answer of 3 root 2 plus root 10 plus 21 plus 7 root 5 all over 4. Okay. Next up, we've got our simplifying through foiling. So let's do this one. We have 4 minus 3 root 3 times 6 minus 2 root 3. Okay, go ahead and pause the video, give this one a shot. Okay, foiling, 4 times 6 is 24. 4 times negative 2 root 3 is negative 8 root 3. Negative root 3 times 6 is negative 18 root 3. Negative 3 times negative 2 is positive 6, and root 3 times root 3 is 3, which is 18 back here. So then combining like terms, 24 plus 18 would be 34 plus 8, or 42. Okay, and then negative 8 root 3 minus 18 root 3 is negative 26 root 3. The only other thing you could potentially do is factor out a GCF, which in this case would be 2. We've got 21 minus 13 root 3. Okay. Okay, one more in that form. Let's do our 4 plus root 5 times 4 minus root 3. Okay, first we'd have 4 times 4, which is 16. Outside, 4 times root 3 is 4 root 3. Inside, 4 times root 5 is 4 root 5. And last we have root 5 times negative root 3, which is negative root 15. In this case, there's no like terms. And so that is your answer. Okay, next up we've got those kind of complicated fraction reducing problems. So I've got a couple here for you. So the first one are the ones that are the complex fractions. So we have 6 times the square root of 4x plus 9 plus 12x over the square root of 4x plus 9, all divided by 4x plus 9. Okay, so for these complex fractions, this is the one we're multiplying top and bottom by root 4x plus 9, because that's the denominator we're trying to get rid of. In that way, multiplying top and bottom by 4x plus 9, what we're actually multiplying by is 1, which changes the form of your function, but doesn't actually change the function itself. Okay, so when we multiply top and bottom, this root 4x plus 9, in the first term, the roots would cancel. In the second term, the denominator would go away entirely, and we'd be left with just the 12x. And in the bottom, we would have 4x plus 9 to the 3/2. Distributing that 6, then we'd have 24x plus 12x, which is 36x. And 6 times 9 is 54. And you've got your answer. The only other thing you could do is to factor out a GCF up top here, which would in this case be an 18, which would give me 2x plus 3. Okay, here's another one for you. We have 2x root 1 minus x squared plus x squared times 1/2 times 1 minus x squared to the negative 1/2 times 2x all over 1 minus x squared. Okay, so here we go. Rewriting this one first, we would have our 2x root 1 minus x squared. We'd have the 1/2 and the 2, which will actually cancel here. And so then x squared times x would be x cubed, so plus x cubed, which leaves me with this negative exponent. A negative exponent, remember, drops it to the bottom, so we have a 1 minus x squared down here. And this is all over 1 minus x squared. Okay, so now we're in our complex fraction form. So then multiplying top and bottom by that root 1 minus x squared. In my first term, the square roots would cancel, leaving me with 2x times 1 minus x squared. In the second term, the denominator would go away entirely, leaving me with positive x cubed. And in the bottom, we'd have 1 minus x squared to the 3/2. Okay. Distributing that 2x, go ahead and drop this down here. We'd have 2x minus 2x cubed plus x cubed, which is negative x cubed. Again, this is negative 2x cubed plus x cubed, which is negative x cubed. And then the only other thing you could do in this problem is factor out that GCF of an x on top. Okay. And then the other kind of weird fraction one, which is the common denominator, guys. So let's do this one. We have root 5 minus 4x plus 2x over root 5 minus 4x. Okay, so this one is not a complex fraction. This one we are not multiplying top and bottom. This one we're finding a common denominator. This second term already has a denominator, root 5 minus 4x, so I don't want to touch this second term. It's already got a denominator. It's the first term that's missing the denominator. And so this first term, I'm going to give it a denominator of root 5 minus 4x. But in doing that, I've now changed the function. So in multiplying the root 5 minus 4x on the bottom, I also have to do that on top. That way I maintain the equality of that first term. I've technically multiplied that first term by 1. And so what we're left with then is the square roots would cancel. And now that we have a common denominator, leaving the second term alone, now that we have a common denominator, I can add them together. 5 minus 4x plus 2x is 5 minus 2x, because negative 4x plus 2x would be negative 2x. And you've got your answer. Okay, one more like that. We have x squared minus 4 to the 1/2 times 3 times 2x plus 1 squared times 2 plus 2x plus 1 cubed times 1/2 times x squared minus 4 to the negative 1/2 times 2x. Okay, so here we go. Rewriting this one, we have our root x squared minus 4. We have our 3 times 2, which is 6, and our 2x plus 1 quantity squared. Back here, we have plus our 2x plus 1 quantity cubed. The 1/2 and the 2 will cancel, which will leave me with just the x. And a negative, remember, drops it to the bottom, and so we would have our root x squared minus 4. Now that we are in this form, we're going to go ahead and find our common denominator. Again, this second term already has the denominator. I'm not touching that second term. Okay, what I am going to do is multiply this first term by that denominator. Root x squared minus 4 over root x squared minus 4. Right, multiplying it by 1 to keep the equality. Okay, and so this first term would turn into 6 times 2x plus 1 squared. The square roots would cancel. And then we have plus, leaving the second term alone. And now that they have common denominators, I can actually combine them. And when I combine them, I'm going to go ahead and factor out their common term, which in this case is this 2x plus 1 squared. They have a 2x plus 1 quantity squared in common, so I'm going to pull that out as I combine them. Okay, and so what I'm left with is 6 and the x squared minus 4 plus x, and since I pulled out 2x plus 1 squareds, what I'm left with is that 1 left over 2x plus 1. Okay, and then distributing, we would have our 2x plus 1 squared, and then 6x squared plus 2x squared is 8x squared. X times 1 is x, and 6 times negative 4 is negative 24. And that's your answer. Okay, next up we've got some solve for x's here. So let's start with root 2x equals root x plus 5. Okay, so for this one we are going to start with squaring both sides, because one of my square roots is already isolated, and actually in this case both of them are isolated. So when I quantity square both sides, root 2x squared would be 2x. Root x plus 5 squared is x plus 5. And then when I subtract the x to the front, I get x equals 5. And then it's always good to double check, make sure that's not for some reason an extraneous solution, that you didn't for some reason miss a no solution. So you do want to plug that 5 back in just to make sure. Root 2 times 5 is the same thing as root 10 equals, plugging in the 5, root 5 plus 5, which is root 10. Okay. Next up, we have root x plus 1 equals x minus 1. Okay, and so one of my square roots is already isolated, so I'm going to go ahead and quantity square both sides. So we'd have x plus 1 equals, and then you do have to FOIL this. I can't just distribute the square. This can't just be x squared plus 1. All right, so you do have to FOIL this, because this is, if I were to rewrite it, x minus 1 times x minus 1. All right, so first would give me x squared, outside and inside would give me negative 2x, and last would give me positive 1. Subtracting the x and the 1 to the other side, we get 0 equals x squared minus 3x, which gives me initially two answers, 0 and 3. And it's possible that they are both answers, but we need to double check, make sure neither one's an extraneous solution. When I plug in 0, I get root 0 plus 1, which is 1. When I plug 0 in over here, I get 0 minus 1, which is negative 1. 1 does not equal negative 1, and so 0 is an extraneous solution. We're still going to check 3, though, just to make sure it's not, for some reason, also an extraneous solution, indicating maybe no solution, that I might have missed that at some point. Okay, when I plug in 3, I get root 3 plus 1, which is root 4, or 2. When I plug 3 in over here, I get 3 minus 1, which is also 2. And so in this case, whoops, 3 is my answer. Okay, and then we're actually going to do one more, because I've got a nice space here, and it doesn't hurt to practice. Let's do root x equals root x plus 5 minus 1. Okay, so this one I actually have two square roots, and so I can isolate either one. It really doesn't matter which one you isolate. So you could leave it as is because root x is already isolated. That'd be fine. Yeah, let's go ahead and do that. It's already isolated. You also could add the 1 over if you wanted and isolate the other square root. Okay, if we square this root x, we get x. Now here you have to FOIL again. It's like this one, right, where we can't just distribute the squared. We do have to FOIL. And so my first would give me x plus 5, my outside and inside would give me negative 2 root x plus 5, and my last would give me positive 1. Okay, and so then subtracting the x, the 5, and the 1. Okay, what I'm left with is negative 6 equals negative 2 root x plus 5. Dividing the negative 2 over, you'd get 3 equals root x plus 5. And then squaring both sides, since the square root is now isolated, you'd get 9 equals x plus 5. Subtracting that 5 over, x is 4. And it's always good to double check, like we said several times. Plugging that 4 back in, you get root 4, which is 2. And then plugging the 4 in over here, we get root 4 plus 5, which is root 9. 3 minus 1, which is 2. And so I know that I did it correctly. And again, I want to emphasize one more time the importance of checking your extraneous solutions. Yeah, it's possible that every single answer that you find is actually the answer, but you want to make sure that you aren't for some reason missing a no solution. You do need to make sure that there's no other extraneous solutions. And so do plug back in, do double check that. Okay, next up we've got our domain. So finding the domain of the function. F of x equals root x plus 3 over x squared minus 2x minus 8. Find the domain. Okay. So with domain, we are looking at the zeros of our square root, which in this case is going to be negative 3, and the zeros of our denominator, which in this case is going to be negative 2 and 4. And since we do have a square root, we do need to test sign, because remember, square roots cannot be negative. If that square root wasn't there, it'd be good to go. but I do have to test sign for that square root. Negative 3 would be a point, but negative 2 and 4, since they zero out the denominator, they will be wholes. Okay, when I take a number left of negative 3, say negative 5, and plug it into the square root of x plus 3, what I get is the square root of negative 2, which is, again, a square root can't be negative, so that's an issue. When I take, say, negative 2.5 and plug it into the square root, what I get is root 0.5. Well, that's fine. That's a positive number. I like that region. When I take, say, 0 and plug it in, I get root 3. That's fine. Square root of 3 I can do. And when I plug in, say, 6, I get root 9. Definitely can do root 9. That's 3. And so that one's good to go. So all of these regions are good. We have negative 3 to negative 2, negative 2 to 4, and 4 to infinity. And you'd need a bracket over here on the negative 3 because that was a point. But all the others will be parentheses because they are wholes and infinity. Actually, in this case, they're vertical asymptotes, but they are absent of a point and infinity. So all of those will be parentheses. Okay? And then one more here for you. We have f of x equals the square root of x squared minus x minus 6 all over x. Okay? So again, pause it if you haven't already because I'm about to walk through it. So we're looking for zeros of the square root and the denominator. So if I were to factor that square root, we'd have x minus 3x plus 2. Which gives me 2 zeros from my square root, 3 and negative 2, and the 0 from my denominator is 0. Okay, so we have 3, negative 2, and 0. We do have to do the number line test because, again, I do have a square root, so we need to check that. 3 and negative 2 would be points, but 0, because that comes from my denominator, will be a whole, or absent of a point. Testing my square root, if I plugged in, say, negative 5, I get negative times a negative, which is a positive. Square roots can be positive. I like that region. When I plug in, say, negative 1, I get a negative times a positive. Whoop, that's an issue. Can't have negative times a positive, so that's outside my bounds. When I plug in, say, 1, I get a negative times a positive, also an issue. Negative times a positive is a negative, and square roots can't be negative. And when I plug in, say, 5, I get a positive times a positive, which is positive. Square roots are positive, and so I like that region as well. And so my answer is negative infinity to negative 2, bracket on both negative 2 and 3 to infinity. Okay, and then our last Unit 5 topic here, we've got our graphing. And so again, we're going to do 2 of each, 2 square roots, 2 cube roots. So let's start with y equals 3 times the square root of x plus 4 minus 6. Okay. Adding that 6 over, we have y plus 6 equals 3 times the square root of x plus 4. And so my initial starting point here is going to be at negative 4, negative 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And then I need at least 2 other points, and you can choose whatever 2 points you want, like we talked about in class, but I tend to go with my ones that make perfect squares. So I'd probably plug in negative 3, because that would give me root 1, which is 1 times 3, 3, minus 6, which is negative 3. So negative 3 would be my next point. Negative 3 is right there. And then I'd probably plug in 0, root 4. Root 4 is 2 times 3 is 6, minus 6 is 0. So when x equals 0, y is 0, which would be right here. Okay, and one more in that form. We have y equals negative 2 root 4 minus x. Okay, so here we go. Initial starting point's already in descriptive form, so I don't have to manipulate it. Initial starting point would be at 4, 0. And then again, you can plug in whatever 2 points you want, but I'm going to plug in 3, because that gives me root 1, which is 1, times negative 2 is negative 2. And I'm going to plug in 0, because root 4 minus 0 would be root 4. 2 times negative 2 is negative 4. And I've got my little arc here. Okay. Okay, next up, we have our 2 cube roots. So we have y equals the cube root of 2 plus x plus 3. Go ahead and pause the video, give this one a shot. Okay, descriptive form, we have y minus 3 equals the cube root of 2 plus x. So initial starting point here would be at negative 2, 3. And then plugging in additional points, I'm going to go ahead and plug in negative 1, because that would give me the cube root of 1. Cube root of 1 is 1, plus 3 is 4. So when x is negative 1, y is 4. And I'm going to go ahead and plug in negative 3 as well. Negative 3, the cube root of 2 plus negative 3 is the cube root of negative 1, which is negative 1, plus 3 is 2. And you can see your little outline of your cubic here. Oops. Okay. And one more, and that's unit 5. We have y equals 1/2 times the cube root of 1 minus x minus 4. Okay, turning this into descriptive form, we'd have y plus 4 equals 1/2 times the cube root of 1 minus x. So initial starting point would be at 1, negative 4. Okay. Plugging in, I'm going to plug in 0, because that would give me cube root of 1, which is 1 times 1/2 is 1/2, minus 4 is negative 3.5. So I'd be here. And I'm going to plug in 2, because that would give me 1 minus 2, which is negative 1. Cube root of negative 1 is negative 1. Times 1/2 is negative 1/2, minus 4 is negative 4.5. Okay? And you have your little outline. Now this one, I will say the outline starts to look a little bit weird, so you might also want to plug in some additional points. Maybe plug in negative 7, because that would give me the cube root of 8, which is 2. Times 1/2 is 1, minus 4 is negative 3. 3, 4, 5, 6, 7. And so maybe you want to plug this in as well, just to give you kind of an aiming point, which you don't have to. Or maybe you also plug in, oh goodness, what would that be? 9, maybe you plug in 9. 1 minus 9 would be negative 8, negative 2 would be your cube root, times 1/2 would be negative 1, minus 4 would be negative 5. Maybe you do that as well. If you feel like you would like to provide a little bit more structure to your cube root there. Okay? So that's unit 5.